Morning, actually. If anything, it feels more like Netherlands. It's raining and dark and gray, and we are on.
Yeah, we're on. Greetings, fellow nerds. Welcome to another episode of Between Two Nerds, where we talk with prominent guests about all aspects of the networking industry, from protocols old and new to industry trends and drivers to up and coming technologies, and as always, things you should know to further your career. And I think we've got a good show for exactly that last topic right now. Hi, Jeff.
Hey, Jeff, great to see you.
Did you have a good holiday?
Oh, absolutely. Skiing.
Oh man, I miss skiing so much. If I would lose some weight and get my legs back in shape, I would be up there. And so I'm kind of envious that you got to spend some time
Let's
skiing.
work on it. I mean, my knees are healed, so I can barely walk unless I'm on skis. Then I just
Well, you know what? Warren Miller, said you're born with a certain number of moguls in your legs and in your knees, and when they're gone, they're gone.
hey,
So,
let's welcome our younger audience. The painful knees are ahead of them.
yeah, exactly.
Guys, great to see you. It's one of my most favorite routing research teams. They do really amazing work. We've known each other for quite some time. They also presented in AT a couple of times for us. So welcome to the show. And today we are going to be talking about a topic that's very close to our heart, BGP security. We all know if you want to steal something, you either use BGP or DNS. Right? So we're not covering DNS, which leaves us with BGP. And this is where this topic is about. How do you make your network secure? How do you know it's actually secure? So it's not wishful thinking, but you actually can say, I'm secure. I'm also conformant to MANRS set of rules and directions as to how to make BGP secure. And without further ado, the stage is yours.
Hello.
Hello, first of all.
Hi.
So, Antonio, I think, did you want to introduce everybody, or just go round robin and let everybody introduce themselves?
Yes. I'm the oldest one here from my team. I'm currently making some research for the university about BGP routing security. I know that Mariano and Tommaso are two great scholars. Mariano, would you tell something more about you and your studies?
Yes. So currently I'm a postdoctoral student at KTH in Sweden. But mainly I'm working on data center networking and programmable networks. But in the past, I worked on routing in general, both in data centers and on the internet. And so that's why we started working with Antonio, basically. Tommaso.
And Tommaso from Rome.
Hi all, I'm Tommaso Caiazzi, a postdoctoral student, researcher at Kadara University, and my research focuses mainly on high-speed packet processing and also on data centers, including routing aspects. And me and Mariano are also the maintainer of Kadara. That is one of a network emulator tool based on container that we also used in this project. So it's also why Antonio reaches us at the end for this. But since the original idea of the project comes from Antonio, maybe it's better that he starts to introduce all the stuff.
Cool, thank you, and glad to have you guys on the show. One of the things I wanted to ask is, before we even get into the slides, I mean, the show's announced to talk about RoseT, but to get to that, maybe I want to first ask for our audience, members of our audience that may not even know the acronym, but before talking about RoseT, we really need to talk about MANRS. Not MANRS the word, but MANRS the acronym. And if you guys could maybe tell us all a little bit about what that is.
Of course. Thank you, Jeff. So MANRS is an initiative started by ISOC, that is Internet Society, and since this year taken over by Global Cyber Alliance. MANRS stands for Mutually Agreed Norms for Routing Security. What's that? We all know here, between nerds, that internet security is also about hygienic routing. Since the dawn of internet, as we know it today, scholars have been wondering how to make this portion of cyberspace more trustworthy. If we say that security is a process, it is certainly one made up of many links, just as in a chain, where trust cannot be left to the goodwill of the operators, or rather, not only to that. So, MANRS is a set of guidelines, we can say, for network operators, for internet exchange points, for CDNs, for cloud providers, for also equipment vendors. For example, for network operators, there are guidelines that comprise 4 actions. 4 actions that are filtering, preventing propagation of incorrect routing information. Anti-spoofing, prevent packets with spoofed source IP address from entering or leaving the network. And action about global information, it is that network operators must publicly document their routing policies, ASN, and prefixes, for example. This is MANRS. And at this point, Jeff, maybe you are going to ask me what RoseT is.
Hey, Antonio, what is RoseT?
I can read your mind. So, what is RoseT? Well, it was for the project, the main idea. RoseT stands for Routing Security Tool, first of all. The idea was born in October 2022. And it was a research object for a PhD thesis in Italy. The thesis focuses on the security of routing policies to the internet of network operators. And the goal is to implement a method capable of verifying the configurations of devices in use within an autonomous system. Also using logical formalisms applied to data extracted from sources authoritative and reliable, for example, regional internet registries and root collectors. We first presented RoseT last year publicly. After that, Tommaso and Mariano joined the project. So now we reached a point that we can publicly speak about the project because it is ready. Not complete, far from being complete, but it's ready for the kickoff. So here we are.
So
Is it fair to say it's basically automating MANRS compliance?
Yeah, so let's try to go
Yes.
into level of details. I think actually here on Between Nerds, we started with in-depth details. We had presentation or talk about ASPA, which is work that progress in IETF to make security better. I think we have at least 2 or 3 different episodes on what RPKI is, how it is used in BGP security. We had all the guests and people who work on IETF on this. But in IETF, we don't work on solutions, right? We work on particular problem. Sometimes we release best current practices, BCPs. So BCP 38 is part of MANRS, right? Filter stuff. Don't advertise stuff that you shouldn't, right? But again, it's a best current practice, and as such, people looked at it but never did something. So MANRS was really the first kind of effort trying to formalize it. And luckily, Microsoft and Google's and Amazon's joined MANRS. That's what really drove it. I actually represented Microsoft and MANRS for some time. But it's still a set of recommendations in text form. So practically, you can there's room for interpretation and actually false. And this is where our esteemed guests come in. They can formally validate that what MANRS wants you to be, you are. So.
Yes. Exactly.
Exactly. The main goal is to let operators have a self-assessment in order to be compliant with MANRS. Otherwise, we should rely on self-declaration. I am good with routing. I am an expert network operator, so don't mess with my network and my rules. No, we should have a method to verify that you're not lying. Okay.
And this is important also from business perspective, because eventually you would like to say, you are not MANRS compliant, I'm not going to peer you. I don't trust route that I receive from you. You are with MANRS, you've been formally validated by tool developed by this gentleman. I'm going to peer with you because I trust you. I trust what I receive from you.
Yeah.
Yes, Jeff, think of a small network operators that wants to buy transit. Who is going to choose for transit provider? If you have MANRS badge, maybe you have some appeal for the small network operator.
Absolutely.
Yeah. So you guys have some slides, I believe. So is this a good point to just jump to the slides?
I think so. So we can check the details. So I will present, but indeed you can ask questions, and we can also switch at some point with the others if they want. So as we already said, these slides are adapted from the RIPE presentation. So there is some introduction about why the routing security is an important topic, and these are some of the reasons. And we already cited the MANRS initiative and the role that it is playing to making the internet a safer place. So as we said, MANRS provides some guidelines for different kind of entities. One of them is the network operators, but it's not the only type of guidelines. But this project currently focuses on the network operators. And as Antonio already cited, there are 4 guidelines or steps that an operator should take to be MANRS compliant. And these are the coordination, global validation, anti-spoofing, and filtering. But at this point, we ask, okay, now I'm a network operator, and I want to ensure that my network is MANRS compliant. How can I verify this? So, Operators may indeed rely on some network configuration verifiers. For example, there is a Batfish, which is pretty like a famous verifier. But these tools have some problems. Primarily, they rely on there is a problem with, okay, primarily rely on simulation, which means that they use models of the routing protocols that may diverge from the real vendor implementations. And in this case, this is a problem. And also they could be complex to understand and use because, for example, Batfish is not really a straightforward tool. You have to configure it, understand the output, and maybe like merge different outputs to have a solution. And most of these tools are incomplete or are early prototypes. So they lack a lot of specific requirements, for example, some BGP RFCs or other features. So in reality, there is no tool to automatically verify the MANRS compliance, and this is why we are here.
And engineer.
And so the validation indeed becomes a really cumbersome process for the operators because they have to either manually check the configurations and policies or use complex tools and check the output of these tools. And this also makes it difficult to replicate the process because if you rely on manual procedures, indeed, if someone comes to you and say, okay, but now tell me again that you are MANRS compliant, you have to redo all the procedures manually, which is not really good. And while indeed ensuring the MANRS compliance is a crucial thing, it's a really difficult task to achieve right now. So what we actually need to verify the MANRS compliance, what are the basic steps that we should take? We first have to gather some information about the autonomous system, some public available information, which we could use to verify the global validation step, which, as Antonio already said, is about exposing the right information on the registers, so on the internet registers. After that, we can take a configuration from the candidates, from the guy who wants, from the operator who wants to verify the compliance. And here the complexity is in understanding the vendor language because an operator could use different routers or different operators could use different vendors. At this point, when we understand the language and we have a model of what are the peerings, we can analyze this configuration and like reconstruct the relationships between the neighbors. And at this point, here comes the emulation. So we can emulate this small network and perform the verification. So this is RoseT, which is this tool that we are developing. And it is, as Antonio said, is the first tool to perform like self-assessment, and it is open source, so everyone can contribute to it. In the whole presentation, I will use this small example to explain all the steps. So it's a pretty simple one. We want to verify the compliance of ASA in this case. So we go step by step. If you have questions, indeed, you can ask. First of all, we have the gather step. And in this step, the candidate provides the AS number. And from this, we can fetch the IRR entry of this of the candidate. And here we can parsing the RPS lang, we can indeed check what's announced and what are the information exposed in the register. And we also take the latest RIP dump from a route collector. Why we do this? Because from these we can filter out the routes originated by the candidate AS, checking the AS path. And for now, we use a prolog script, which is like a separate entity from the rest of the code, because Antonio developed it separately. So for now, it's a prolog script that verifies that the set of networks announced to the transits in the wild, so in the internet, and we can get them by the rip dump, is equal to the set of the ones defined in the IRR entry, and vice versa. And
Mariano, Mariano,
Go ahead.
excuse me.
Go ahead.
Just to stress that the keyword of this slide is prolog.
Yes. When Antonio gave us the code of prolog, we said, prolog.
We were a little bit scared.
Yes. So and indeed, for now we focus on transits, so on the upper peerings. But in the future, we plan to extend the verification on all the peerings of the autonomous system. So at this point, if we pass this check, it means that the information exposed in the registry are valid, so we can go ahead. And the candidate can provide us the configuration to verify. So we have a vendor-specific configuration, and indeed we need to transform it into an agnostic format that can be easily processed in the next steps. So how can we do this transformation? So currently in RoseT, we exploit Batfish, but only because I said Batfish is not good. But here we use Batfish only for parsing the configuration, because it implements almost all the parsers for all the vendors' syntaxes, and translates them into a unified format that we can further process in the pipeline. But as I said, Batfish lacks of some important features. So for example, currently it doesn't support IPv6. So whenever there is an IPv6 address assigned to an interface or a route or a peering, it's totally ignored by the parser. So what we do, we take the Batfish output and we use it as a baseline, and we extract some the missing information. So basically the IPv6 information right now, using a parser that we built.
Mariano, question to you. So if you look, especially at routers that are used at the edges, mostly Juniper Cisco, they give you reasonably well-defined YANK models with regard to configuration, right? Which provides pretty good level of abstraction, right? There are some deviations, obviously, but it's strictly typed. It actually allows you to derive content and context without trying to parse, because you can configure router in millions of ways, right? Especially something like Juniper or ISXR. So why not using YANK and parsing it directly?
Yeah, I think it's this. We also, Antonio can answer, but I will try to answer. Mainly because I mean we want to be as much agnostic as possible, because it's not really certain that a small provider or a small operator is using the YAML model, or I don't know if it should be configured separately from the normal configuration of the router. But indeed, we could rely on that in the future. So
yeah, this is for sure a path to try for the future.
Yes, even because as you said, parsing all the syntaxes or how they configure the router is not really straightforward. So maybe relying on the YAML should be.
Have very rich policy language, like again, you can configure things in million different ways and feel we're doing different million things. parsing is really, really complicated. Both Jeff and I, we work at Apple at some point in time. And at some point in life, we decided we don't do gray stuff. You want to deploy something, you raise a configuration, we do it from scratch. It's impossible to read and analyze someone else's configuration.
Yeah. Yes, I agree. Yeah, we tried with some configurations. I mean, we have some configuration files, and we used them to test the software. So and in that case it worked. But indeed, as you said, it's just one example. Maybe different operators could configure it in different ways. So yeah, we could dig into the YAML. No, Yang, sorry, or YAML, I don't remember for sure. Yes, the Yang. Yeah. I don't know if Antonio wants to add something on this.
I think it could be the right path to extend the work, but the main part of this work is on the emulation.
Yeah.
So if we have a Cisco XR router or Junos in production, we can put the configuration in our emulation SandLab, just as is, with no cut, with nothing, just as is, your configuration in the router. So it could be complicated, it could be wrong, it could be right. It doesn't matter, because it's self-assessment on another router.
So you're assessing behavior, not particular set of configurations.
Yes.
Which is the right thing to do.
Yes. But indeed, you need to understand what is the minimal topology. So for example, this is my AS and these are my neighbors. And this is the only thing that we actually derive from the configuration. And then with the emulation, we do all the rest. So I will get into that in a bit. Okay, so after this, we can go into the third step, which is the analyze step, as we called it. And so now we have this agnostic data structure holding the main information, but we don't know what are the relationships, as I said, between these AS. So in this case, we rely again on the higher entry to set the relationships. And now we can trust this information, since we already passed successfully the first step, so the gather step. So we can rely and we can trust this information. And so at this point, we have the minimal network with the relationship in place. And for being consistent and for being a more realistic network, we plug this dummy gateway to all the providers. And we use this fake gateway to interconnect all the providers in our network to propagate a default route top-down, and to have an hypothetical AS where we can insert some hosts that we hypothetically think are on the internet, let's say. And so after this, we use the rip dump again. And for each AS, we add the prefixes originated by each of them. And while in the internet AS, we define the default, both by V4 and V6. And here in this example, we only show the direct peerings between ASs. But if ASA has a multi-hop peering, we also model it in RoseT. Okay. So now we are at the emulation step, which is maybe the most important one. So we have this intermediate representation of the network, and we want to transform it into a runnable network scenario. So what we do, we use Kadara, which is, as Tommaso said, our network emulator, which we actively develop. And it is an open source emulator indeed, based on containers. And we transform our intermediate representation into a runnable network scenario in the language and syntax of Kadara. And for now, we represent each AS with a single router, but indeed, this is not realistic, at least for the candidate AS. So for now, this is the implementation, but we plan to expand it and support different and multiple routers. And for all the routers in the network, we accept the candidate. We use FR routing because it's easy to configure and it's open source, so it's better for us. As for the candidate one, we use the specific vendor container that it's derived from the configuration. And for now, in RoseT, we support Cisco iOS XR and the Junos. But indeed, the tool can be easily extended to support other vendors. And this is something that we are working on even with the guys from MANRS. So what we do is that we run the emulation with this minimal network, and we wait for the convergence of the BGP protocol. And after that, we can start performing the verification of the anti-spoofing and filtering steps. Before that, we had two hosts which act like a client, both in the candidate AS and in the internet. So it emulates an host in the internet, somewhere in the internet. So let's start
Mariano.
with sorry, go.
Mariano, I just would add to this that we are going to replicate your little world, your little internet. So your router has relationships with 1, 2, 3, 4, 5, 100 other routers. We are going to replicate that. Okay, I would like to stress this point because we are simplifying, okay, but we are also replicating your internet, your view of the internet.
Yes. Indeed, this network is pretty simple, the example, but you can, have a much more bigger network. And with Kadara, we can emulate really large networks. Tommaso can add something on this if he wants.
Yeah, as Jeff know from CBuild that we presented at IETF, Kadara is capable to span over multiple servers using Kubernetes as the backend for the virtualization. So we can emulate more or less arbitrary networks as we want without constraints.
Yes.
So I would really like our listeners to listen carefully to this. This is the best emulation tool I've ever seen in my life. So,
Thank you.
So we are going to have whole team back talking about Kadara and what they did with reef testing, some other stuff. If you are interested in modern Kubernetes-based environment, you can test conversions, you can test robustness of routing you are using. This is probably the best tool, and it's available. You've got active developers. There's a lot of people participating in this. It's really good. Pay attention to this.
Yeah.
Thank you.
I would like that if Tommaso can say something about performance of Kadara. I mean, if a candidate has, for example, 1,000 of peering relationship, it means that we have to switch on 1,000 routers in Kadara. Is it possible in a timely fashion? I mean.
Yes, because as I said before, thanks to Kubernetes, we can scale up as we want, and also Kadara is all multi-threaded, so it's very fast in startupping the machines and setuping them before starting the experiments. So I don't know, for emulating something like more than 1,000 router, you need something like 15-20 minutes, and obviously it depends on the cluster and on the hardware you are using for performing the emulation. But in our experiment, we saw that. The interesting thing is that you can also run Kadara in the cloud, so you can use Kubernetes in the cloud and then install Kadara in your cluster in the cloud, and so you have no limits and you don't need to have a physical testbed to set up.
But when you start touching it and you're bringing up topology, it feels like you are driving a Ferrari. And it's powerful.
Yeah. And we try to make it as fast as possible every time, so it's still in the work.
Well, let's say that 20 minutes for 1,000 routers is less than reality.
Yeah.
No?
Yeah.
Yeah.
So,
yeah, but if you compare this, startup times with a system using VMs, you will never spawn 1,000 VMs in the same time. So it's surely better, let's say. Okay, so if there are any other question, otherwise I will go ahead and I will dive into the. Okay. So let's go ahead. So we start with the anti-spoofing check. And the anti-spoofing check is done on each provider. And so we take each provider, and here I will show it only for one provider, which is ASP. And what we do for each of them is that we first insert another client here. And then we assign... Okay. Then we assign the IPv4 and IPv6 addresses to each client. Here I will only show the IPv4 for simplicity. And the challenge here is to choose subnets that are currently announced and reachable by the candidate AS. And also we need to choose a valid random IP subnet to assign to the internet host. And this subnet should not overlap with all the other prefixes in the network, since it will act as the malicious subnet where the spoofing will be performed. So now, after we have all the IPs in place, we can perform the actual check. What we do is we use SCAPI to send and craft an ICMP packet from the candidate client host to with the spoofed IP source IP, and the destination is the provider. Now before doing it, we put a TCP dump on the internet client interface to see if it receives any packet, since this is a packet which is crafted to be received by the internet client. So we send this packet, and two conditions can arise. If the packet is forwarded by the candidate router, it reaches the provider, and at this point, we check if the packet is then received by the internet client. And if so, it means that the configuration is not compliant, since for the anti-spoofing, the candidate AS has to block spoofed packets with the spoofed IP source address. Conversely, if the candidate correctly blocks the packet, it means that there is no packet received by the internet client, and so the configuration is compliant. And as a double check, we also verify that legit packets, so non-spoofed packets, are correctly forwarded and received by the provider. As I said, the same check is repeated for IPv6 if the peering is IPv6 enabled. And right now we are using ICMP, but it could be a simplistic way to check it. As a future, we could work on replacing it with more sophisticated checks, but for now, this works and provides reliable results, at least for now. Okay, so now there is the filtering check. And this one is done on the customers. So here there is only AST as a customer. And first of all, we select a malicious subnet, and that should be announced from the candidate from the customer to the candidate. And as for the other check, for the anti-spoofing check, we should select a valid random IP subnet that must not overlap with the other prefixes in the network. So now we announce the subnet from the customer, and we wait for the BGP announcement to be propagated to the candidate. And here, two conditions can arise. The first one is that the malicious prefix is indeed announced from the candidate to the providers. And to check these, we check the FR routing control plane to see if the announcement is received by the providers. In this case, yes. And so if this happens, it means that the configuration is not compliant. Conversely, if the malicious prefix is blocked by the candidate, so it's filtered out, the configuration is compliant. And as for the anti-spoofing, even in this case, we repeat the check for IPv6 if there is an IPv6 peering. So this is the whole pipeline. Then we have some conclusions here in the slide, but we can get to them later if we want to discuss something.
So if I may ask a couple of questions.
Yeah.
So you decided to analyze the behavior rather than formalize the configuration. Statically, you could formalize the configuration without sending real updates or real traffic saying it is not going to pass particular update because of its configuration. So I'm interested in, there are a couple of companies that actually do formal validation of policies rather than trying to do what you do. And I think your approach is better because it's closer to what it is. All routers have bugs one way or another. So what you see is not necessarily what you get. But I'm interested in your logical process as to doing this versus going in more academic approach where you would formally analyze the policy language and decide what's allowed, what's not allowed.
Yeah. I can start answering. Otherwise, Antonio, if you want to answer, maybe. Okay.
Well, I want to say that maybe the formal verification should be the best verification ever. But it's very difficult, according to me, to get to a method that is very, very precise. It needs a lot of time and studies. This way, we are also checking, as you said, Jeff, router bugs or other obstacles that anybody can find on the road to the verification. So I'm the opinion that the formal verification could be the best option, but it's very hard to accomplish.
Well, and it's as we were all talking about at the beginning of this, trying to. There's so many different ways to configure a policy. Especially if you're talking about across multiple vendors, that trying to pull a vendor-specific configuration into an abstraction can be that can be a very complex task. But simply doing a live anti-spoofing and filtering test, it seems then it either works or it doesn't work.
Yeah, so I asked this question because all of you are coming out of academia, right? And
Yeah.
you talk to 90% of the people, they'll try to formalize it rather than do the real test, which is, again, I completely with you. It's much better approach. It's much more higher fidelity, and you see what you get.
Yeah, and also in this way, well, if to the operator can continue to do what so configuring the router as he done normally. He don't need to understand nothing about how the tool is made internally or about formal verification. So we think that is the simplest way to build this type of tool that then needs to be used by operators and not by academic formal verifier. So
I fully with you, 200%.
Yes, but as I will add something to the discussion. I remember that at the beginning we discussed about going towards formal verification or emulation, but I remember that I convinced Antonio mainly that emulation was better because you have bugs in your router. Usually you could have bugs. So if you do the verification with the formal with a formal verifier, as I said in the slides, well, you don't have the same bug. If something is broken in the BGP implementation, you have that bug in your network. So you verify the compliance with what you have in the network. So with the bugs that you have in the network, basically. So I think that this is much better. But we started developing it not with a focus on academia, but more on the industry. So for MANRS and all the network operators. That's why we chose this path, basically.
So given your focus on industry, I would really like you to tell our listeners how they can get in contact with you. How can they use your tool? What is the potential engagement? I assume there are some commercial considerations behind your tool. So let us help you to help others.
Yeah. Cool. Antonio, maybe it's the guy that could answer to this.
Jeff, this is the point, I guess, because this all started just like a game or a challenge, but the useful part is the main part here. So talking with colleagues, other operators, etc., they said they would love to use the RoseT to achieve the compliance with MANRS. So we are going to present our project to vendors, for example, and we had a lot of interest, to be honest. Maybe not only to grab the software, grab the project, but just to fund the project. Okay, there is an interest to see our project go ahead, and we released this part of software on GitHub. And we are going to present also to MANRS in the new form of GCA instead of ISOC, because ISOC is already aware of our project. So we hope that we can get some funding in order to fill the blanks. Really,
probably you would be the right place to get the grant. So please do let listeners know where you can be found, how to contact you, how to get a hold of the tooling and everything else.
Yes, here I have I have a QR code on the slide. This is the GitHub repository. Tommaso, sorry, I
that you
interrupted
can
you.
use for discussing, opening issue, feature requests, and all as you want. And also you can easily find on internet our emails, or I don't know, our LinkedIn profile if you want to get in contact and talk also privately maybe. So we are open to contribution also, because we really need contribution for going further with this project from all the sides, from developing side, from vendors to have the possibility to use their software, from operators to understand what are their needs. So don't hesitate to write us and to get in contact with the team.
Fantastic. Thank you so much for joining us today. And as I said, it's not the last time you are here. We are going to talk about Sybil. Again, I think it's really fantastic work you've done. Antonio, wish you luck. And this is very much needed. I think you're addressing very, very missing part in validation. And again, as much as I love people to trust me as an engineer, sometimes I want something to be really validated by tooling.
And I can't let everything go yet without plugging Antonio's book. Antonio and a couple of co-authors. This is a great book on BGP. It's vendor neutral. You can find Cisco. You can find Juniper configs in here. And
amazing book.
Good book.
Thank you. Thank you.
Thank you.
So we are going to add also two words you, Jeff, said previously, RPKI and ASPA, of course, because this could be the base of a new program inside MANRS that is MANRS Plus. Is an enhancement of MANRS that have more verification, more controls, and more aspects to be viewed. So that could be our commitment for the future.
So FRR has fully working RPKI implementation. It's been deployed in the wild. ASPA is still in discussions. It's still kind of early days, but if someone wants to write the code, contribute to FRR as kind of member of FRR community, I welcome you to do so. Thank you, guys.
Thank you.
Thanks, guys, for joining us.
We'll see you soon, Buck. Ciao.
Bye-bye.
Bye.
Thank you.
Thank you. Thank you. Bye.